Hello and very welcome to the Alexanderson Day, this 3rd of June at the World Heritage Grimeton radio station in Sweden. We are here to try to start the almost 100 years old radio transmitter SAQ and send a message at 2 o'clock p.m. CEST or 12 o'clock UTC. We are members of the Alexander Grimeton Friendship Association. My name is Anders Börjesson and I will be the host today. On my right side here I have Jan-Åke Gylling, the main operator today, and Kai Sundberg will be the radio operator. And that is the team today. This year, the World Heritage will turn 100 years. But 2025 is the year to celebrate, as the inauguration of the radio station took place the 2nd July 1925. But we start celebration on the 1st December, the same date as the station was put into commercial operation 100 years ago. There will be a number of activities from the 1st of December to the 2nd July, when the official celebration will take place. You can read more about that on the website grimeton.org. By that, it is time to take a tour in the facility. Everything that is painted black here in the transmitter hall belongs to the old long-wave transmitter. Here is the Alexanderson alternator with the high-frequency generator here, an invention by Ernst Alexanderson. It is here the radio wave is generated, and it contains a rotor disc of massive steel, 1.6 meter in diameter and 7.5 centimeter thick at its periphery. There are 488 cutouts on this periphery filled with non-magnetic material brass. It rotates in a magnetic field, and when it is up in speed, it generates 17,200 magnetic alternations per minute. And this alternation is picked up with 64 anchor windings and conducted up to the collecting transformer in the antenna modulator. You can see up there. The disc is driven by the main motor via a gearbox that shifts up the speed almost 3 times. The motor speed is directly related to the frequency, so it is of great importance that the motor speed is correct. So we are controlling the motor speed by handling the voltage to the stator and to control the resistance in the rotor. We are now going to the auxiliary machines area. Behind me here we have the transformer room where the power comes into the station. There are also 4 transductors that can control the power, the voltage to the main motor. There are also a set of transformer for the main voltage. Here we have a set of rectifiers that this gives or provides 500 volt DC, and it is controlling the transductors in the transformer room. One is a backup. Here we have a set of a transformer that gives 125 and 250 volt DC. That is used for the relays and for magnetizing, amongst others, the high-frequency generator. Down here we have also cooling pumps and rheostats that is used to control the resistance in the rotor, but I will tell you more about it when we are starting up. To control the motor speed generates a lot of heat, and here we have cooling fans. We will use cooling fan number 2 today. It is here to provide compressed air for blowing out arcs and cools the big contactors here in the relay corridor. The signal from the telegraph key enters the transmitter here at the telegraph relay and are then amplified in 3 steps 2,000 times. The last step with these 2 relays, one that is keying the magnetic amplifier in the antenna modulator, and the other is support to these 4 contactors that is a part of the speed control system. We are moving on to the control panel. On this side, we have oil switches for the main power and to start the main motor. There are also switches for rectifiers, and up on the panel we have an ammeter that we control the power to the motor. In the center here we have the so-called automatic speed control system. And with feedback from the high-frequency generator when we are up in speed and holds the speed constant. On this side we can see here's a lot of meters, and here we can monitor that everything is okay. We can monitor the speed of the motor, the voltage of the motor. Up here we can monitor how much amperage that leaves to the antenna. Here we also have nice switches to magnetize the high frequency generator. There is also push buttons to control the rheostats. Here we have a small telegraph key to control that everything is okay before we go out on the antenna. And that was the short tour in the facility. We have done some preparations in ahead. We have controlled that all the machines is running well. We have controlled that there are lubrication in our bearings. We have connected the antenna to the antenna modulator over there. And we have also connected the transformer room to a transformer outside in the transformer house. So now I will ask Jan-Åke to go out and to the switchyard so that there are no one close on, because there will be it will be noisy when we start up the transformer. The transformer that we will connect converts 50 kilovolts three-phase to 2.3 kilovolts two-phase, and it is power supply to our transformer room. Yeah, Jan-Åke, it's okay. Yep. Now we have 2.3 kilovolts two-phase into the station, and I will ask Jan-Åke to stay by the emergency switch, because we are handling high voltage. Now I'm down here on the left side of the control panel, and I have a look at Jan-Åke, and I will switch a 0 voltage release and then start the main switch. Now we have 440 volts three-phase to all the auxiliary machines. We have an alarm bell ringing because we have no cooling water, or we are also lacking oil pressure to the bearings. We are going down to the cooling pump. The centrifugal pumps, we will use pump number 2 today. And Jan-Åke, we start to open a bleeding valve on top of the pump house and open for water supply. He is now listening in a drainage pipe that there will be just pure water coming out. We have to listen. Jan-Åke is satisfied. He closes the bleeding valve and he's starting up the pump with a YD coupler. Now it's running. No. Now Jan-Åke will open a pressure valve against the water pressure. It is hard work. On the manometer on the wall over there, we can control that we will have the right pressure on the cooling water. The nominal pressure is 2 bar or 30 psi. Now we get cooling water in a closed loop via rheostats that we have here, and the alternator and the magnetic amplifier. Jan-Åke will control the liquid levels in the rheostats, because the liquid gets hot and evaporates, so sometimes we have to add some water. Here are 3 rheostats. One is a backup. They are used to control the motor speed. This is a start resistor, and it will hold down the initial power to the motor later on it is used to fine-tune the motor speed. It is connected to the rotor on the main motor via slip rings and cables. Here we have a control rheostats, and this is immediately connected connected to the start resistor when we are operating the telegraph key, and that's the way to hold the motor speed constant. Now Jan-Åke is entering the relay corridor, where he's going to start up circulation pumps in the rheostats. Otherwise, it starts to boil when we are starting up the motor. Because we have 440 volts on open contacts, he will use gloves. He has to be careful, because this is built with a standard of the 1920s. Yep, we are ready, and we are going back to the control panel, and Jan-Åke will add the alarm bell again, and we have a persistence alarm because we have no lubrication. Jan-Åke will solve that, will start an auxiliary oil pump. Yeah. Now we are ready to start up the main motor, and I will ask Jan-Åke to go to the emergency switch, because now we are handling 2.3 kilovolts two-phase. There are oil switches to extinguish electrical arcs. Now I close 0 voltage release, and now we have started up the main motor. You can see it's slowly starting up. There's a lot of masses to be started up. Only the rotor disc weighs about 1,500 kilograms. We are now we are controlling the amperage to the main motor on the ammeter up here. We have an amperage target, 75 amps. We are now waiting for the internal oil pump to provide oil pressure, and then we can stop the auxiliary oil pump. Just now we are protecting the main motor by 4 transductors and the high resistance in the start rheostat. Just now we have about 1,200 volt, and as I said before, the amperage just now is 100 amps. Later on, we will have full voltage to the main motor. When we have reached 75 amps, Jan-Åke will close the switch to start up the rectifier for 125 250 volt DC, and then a rectifier for that gives 500 volt DC. I think it's okay. And now the 125 250 volt DC. We are going to the other side of the control panel, and Jan-Åke will close a nice switch with 250 volt DC to magnetize the 500 volt DC generator that gives full current to the transducer. So now we have 2300 volt incoming. Yep, now we got an alarm, and we can stop the auxiliary oil pump. Now Jan-Åke is going to increase the liquid level in the start rheostat to lower the resistance in the rotor, and by that give even more power to the motor. Yep. Now Jan-Åke is also increasing the liquid level in the control resistor to get the right level at the start when we are using the telegraph key. We have 700. You can yes, go on. We have now 700 RPM on the motor, and Jan-Åke closed another nice switch and magnetized the high frequency generator. So just now we have a radio wave generated inside the generator. We are not out on the antenna yet. Now Jan-Åke is going to fine-tune the transmitter. He begins with the start resistor. And on top of the control panel, you can see the frequency counter. Just now, 10.2 kilohertz. Yeah. We are still having a 2,300 volt to the main motor, and we are aiming to lower the voltage. It's a better voltage to control the speed. As you hear, most of the equipment here are aimed to control the motor speed. Now we can see the gauges react. Now we know that the automatic speed control system is working. The automatic speed control system, there is a resonance circuit with feedback from one of the anchor windings in the generator. the voltage 1900. We have 17.2, nearly 2 kilohertz, and we are satisfied. So Jan-Åke will turn on the cooling fan. We must start up the cooling fan so we can blow out arcs, electrical arcs on our contactors and to cool them. We have to do that before start up keying the machine. Yep. I think we are satisfied. Can we... Are you ready to close the antenna? Nice. Yep. Go on. Now Jan-Åke is fine-tuning the transmitter to get the right frequency, the right voltage, and the maximum power out to the antenna. He also is working with a variometer. It is an adjustable inductance, a tuning coil in the antenna modulator to fine-tune the antenna. Du? Har du lagt till antennen nu? Ja, bra fisk. Okay. Yep. We can switch on. Have you we will turn on the key switch to the operator's table and start the punch tape reader. This punch tape reader is converting the characters on the tape to Morse code. And just now it is sending the message VVV the SAQ out of the antenna. So now radio enthusiasts over the world can listen and turn in their radio receivers. We had problem with our readers, but radio enthusiasts in Netherlands and Germany helped us. So now we have two working readers, and one is a backup. I think, alltså, Jan-Åke, det är okej, vi går. Okay, we will take a short walk out to the antenna, yes? Oh. Out here, it's heavy rain. Just in front of me here, we have the cooling pond with the fountain running. Back of me, we have the 6 towers against the cloudy sky. They are 127 meter high, and the cross wing up there are 46 meter wide. It was the highest building in Sweden when it was built. The antenna is 2,200 meter long, and the ground net has the same length, but is 500 meter wide with 180 kilometers buried metal wires. We can follow the wires up, the 8 wires up to the 6th tower. That is the top net. It is there to distribute the power from the alternator and the signal via the first antenna coil. And to the ground it gives a capacitance, and together with the inductance of the 6 antenna coils, it resonates the antenna to 17.2 hertz. The tower was built by the antenna was invented by Alexanderson, and the inventor, and the station was located here because it was the best place. We can send the signal on the great circle out on the sea in south of Norway and north of Denmark to the receiving station in Riverhead, New York. I think we start up and go back to the station, but first we can have a look at our new restored snow melting house over there, and then we can also have a look at our beautiful main building built in a new classical style. By that we are going back into the station. On the right side here we have the auxiliary machines running. Sounds nice for me. We are getting close to sending the message, and Kai is preparing, and we have a look at the transmitter. I think you are satisfied, Jan, okay? Really nice. So just now we are just waiting to turn off the reader and Kai to prepare. Ska vi bryta vid 1 minut eller ska han få styra? En minut, så trycker jag där. Half a minute left. So we have stopped the reader and Kai is preparing. Det tycker jag är rekord. Vänta. Thank you, Carl. That was the message from us in Grimeton radio station this Alexanderson Day 2024. It told us that in the summer 1924, the radio station was getting completed with 2 Alexanderson alternators, each with 3 important developments: a rotating alternator, a magnetic amplifier, and a multiple-tuned antenna. And there was also important information about the upcoming 100 years celebration of the World Heritage Grimeton radio station. And by that, it is time for us to stop the machine, which we do in the opposite way of starting up. So Jan-Åke will open the now switches. Right. Ja.
Är det något att höra här, eller?
Ja, det är de. And I will, and he will open the switches for the rectifiers, and I will stop the machine. And Jan-Åke will go to the other side and decrease the levels in the rheostats to the start position. When the motor speed is slowing down, the internal oil pump will no longer handle the lubrication, so we have to start the oil pump again. But in the meantime, I think we can stop the cooling fan. It takes about 9 minutes to complete stop. By that, we will thank you. We have done our mission today. We have started the transmitter and sent a telegraph message to the world. We thank you all for being with us on YouTube, by your radio receiver, and here in the transmitter hall. We hope that you have enjoyed the starting of the transmitter and sending the telegraph message. Please send us your listeners' report. It's of great importance for us, and we will answer you with an EQSL. Check in on our website, alexander.n.se, and you get more information about how to send a listener's report and how to be a member. Of course, we want you all as members. Join us. Welcome back. Bye-bye. Bye. Yeah. The next item on our program here in Grimeton.